Hello, my name is Larry Carpenter, and I'm a Master Product Manager in Oracle's High Availability Systems. I focus mainly on data guard, but I cover the whole maximum availability architecture as well. I've been working with data guard since the first release in 9i Release 1, and I've been in this industry for about 40 years, focusing generally on high availability and disaster recovery for the last 25. What I'm here today to talk to you about is Active Data Guard and Data Guard itself and what's new in Oracle Database 12c. We'll start off first with some of the new features in the base product that's included in every Enterprise Edition license for the Oracle Database. As you can see over the years, Data Guard itself has been geared towards data protection and maintaining the high availability of your systems and your databases, because that's where your applications actually function with their data. We do concentrate a bit on performance and return on investment, but as our prime directive with Data Guard is to protect your data, most of the features in the base product have been covering those kinds of features, such as corruption protection, detection of lost writes, asynchronous transport to give you minimal data loss, and synchronous transport to give you zero data loss in the event of a failover. As well as that, we are working on trying to reduce planned maintenance and being able to use Data Guard for things like rolling upgrades and standby first patching, which is the subject of another presentation. Zero data loss has fast becoming the mainstay for many applications because losing even a single transaction can be very difficult. The problem with synchronous transport is that we have to wait for the response to come back from the standby itself before we can actually allow the transactions at the production database to commit. One of the things we've done in Oracle Database 12c with Data Guard is reduce the impact by implementing a feature called Fast Sync. Fast Sync itself is the ability to do synchronous transport to your standby, but to eliminate the I/O it takes to write that information to the standby read log file, therefore reducing the amount of time it takes for the transport to occur. If you look at the way we do things today, as of 11.2, we have already started things in parallel, which reduce the initial impact of synchronous because we used to do them serially with the log writer's commit. So when somebody says commit at the database level, the log writer and the Data Guard process simultaneously take that information, and the log writer writes it to the online read log file, and the Data Guard process will send it to the standby, where it is written to the standby read log file and then returned back to the primary database. It's not until both of those things have completed that the log writer can then tell those transactions that they have been successfully committed because they are protected at a standby database. In 12c, we change that so that we speed up. In other words, we take out part of that round trip to the standby database. Now, when somebody says commit, the same function happens simultaneously, but instead of waiting for the I/O at the standby, what we actually do is return the answer to the primary database the moment that it is at the standby in memory. The I/O to the standby read log file is actually done after the fact in an asynchronous manner. This takes out the I/O time it takes for that standby read log file write, therefore reducing the amount of time for synchronous transport in a zero data loss mode. This is available for the maximum availability protection level, meaning that you cannot use it in maximum protection because there is a very, very small window where we could lose data if you lost the standby read log file at the exact same time you lost the primary database. While this potential occurrence is very, very small, it could happen, so therefore at the guaranteed maximum protection level we do not allow this. This is done merely by taking out the affirm attribute in the log archive desc parameter and saying no affirm. So now to get this you'll just say sync no affirm. In the broker we actually added a new keyword called fast sync to enable the ability to send zero data loss transmissions in this manner at a reduced impact to your production database. Several other things that have happened in Data Guard is a lot of the Data Guard broker support for all of these new features, such as the ability to use fast sync. We've also improved lag monitoring and giving you much more warnings when things do occur. We've improved the switchover robustness so that if something does happen during a switchover, you can resume where you left off rather than having to recreate everything. We've also added a command for validating database role transition readiness. And of course, we have support for some new features called FARSync, which I'll talk about in a minute. The broker support for SASync, as I said, is merely a keyword in the transport mode that you define when you create your broker configuration. In the past, in 11.1 and 11.2, you had the capability of saying sync or async. We've only added a third keyword called FastSync. However, you can see here that I'm talking a bit about a new property called redo routes. This redo routes property allows for much better configuration of a DataGuard setup in the DataGuard broker so that things will work exactly as you planned no matter which database is the primary. I will dive a bit deeper into that a little bit later on in this presentation. Lag monitoring is something we've added and actually backported to 11.204 as well, so that you can set thresholds for the transport lag, the apply lag, and also how long you've been disconnected from the primary database. This allows the broker to signal warnings whenever anybody does a show database or a show configuration, and these warning levels will be percolated up to Enterprise Manager so that the Enterprise Manager will notice the errors much faster as well. As you said, you can see here, you say edit database, set the name of the database, set property, apply lag threshold, and some number. The same thing applies for redo and disconnect. The only one that actually has a default is the disconnected. We set that default to 30 seconds automatically for you so that when a disconnect happens, we will time out and start throwing errors within 30 seconds. You can, of course, lower that or raise it depending on your configuration. Now, the one that's extremely important for many of our users and something that has been requested for a long time is this concept of validate database. In other words, am I ready to do a role transition? Today, we go through lots of manual steps looking at, do I have any gaps? Is the standby caught up? Are the parameters set the same? Am I going to have the same functionality on my new production after a role transition? Validate database goes out and does all of those health checks on your configuration. This means that when you go and say validate database and your production database, we will check the database and do multiple health check items to make sure that you are ready to go. If you then say validate database and one of your standbys, not only will we compare that standby with the primary database, but we'll make sure that it is ready to go for any role transition at that particular point in time. So this particular command adds a lot of functionality to the DataGuard broker, which allows you to do these role transitions with much more confidence that they will succeed. However, the moment you do a role transition or a validate database, anything can happen. In the past, if a switchover had a problem with the DataGuard broker, there was a manual process to unwind what happened and try and fix what has occurred. Now, you'll be able to fix the problem and just resume the switchover with the DataGuard broker, which means that you no longer have to reconfigure things or drop the configuration and recreate it. You can merely just say, I fixed the problem, switch over, and it will pick up where it left off and finish the job. Another thing that's important in DataGuard is the whole concentration on the speed of role transitions, because failovers are very important because things have happened. However, for planned maintenance, it's extremely important that we make these switchovers as fast as possible because that's the only outage that your application should have to take. So we've improved the speed with which we do it. We've also simplified the DDL so that you only have to do a single command to do the switchover from SQL+. And again, it's a single command from within the DataGuard broker. If you look at some of the things at SQL+ level, not only do we have the single command, but we do have a verify command, which does a subset of what the broker's validate database command does. That means that you can, even if you're not using the DataGuard broker, which we do recommend, you still gain some of the functionality of the verify so that you can say, hey, am I really ready to switch over at this particular point in time? The other thing is that there's a force clause. If something has happened where we think, well, we can't really complete this, you can force DataGuard to say, just do the switchover, I'll solve the problems later. If you look at our timings, this is an extremely important factor of DataGuard because over the years, since we started with DataGuard in 9i, we've been trying to reduce the things that happen before the switchover completes that get in the road of actually getting the new production database up and running. If you look at this slide, you can see that we're now at a point on a single instance where a failover should just take 9 seconds to actually go from recovery to open, ready for connections. And on a switchover, only 19 seconds. If you look at the chart and go to the right, you'll see that as you add connections, the time goes up, but even those times for failover and switchover are greatly reduced from what they were from 11G. This is because we have moved as much as we can to after the open so that your users can start to connect immediately with very, very little outage. So these benefits are going to be something that's going to make your life a lot easier, because now, as we say, well, switch over to do a standby first patch, you'll be less reluctant to say, well, that's an outage, because that outage is going to be much smaller. Another important thing for many of our users is the whole ability to separate who can do what on a database. In today's world with 11G, you will have to use sysdba. That means that all DataGuard DBAs have to have sysdba privilege. This allows them to do more than what they should be able to do with just DataGuard. We've added several new roles to 12c, one of which is sysdg, which allows a DataGuard DBA to only do those things that are necessary for a DataGuard database administrator. We added 2 others called sysbackup for RMAN work and syskm for TDA key store operations. So we've been able to separate the roles out so that a person requiring DataGuard capabilities no longer has to have sysdba. This role is a username, sysdg, but it's also a role that can be assigned to any other user. So database administrators who have sysdba to do just DataGuard work can now have their sysdba role revoked and the sysdg role added, and they'll still be able to do their job. This gives much more security to your database because you no longer have to have sysdba, which allows full access to everything in the database just to perform DataGuard duties. Something else is added in Oracle Database 12c that is important to a DataGuard environment that DataGuard now supports is the ability to relocate online data files. In the previous versions of Oracle, if you needed to move a data file, that data file needed to be taken offline, copied, and then put back online. And that could be done at the primary or the standby. However, that meant an outage for any of the operations that needed to happen on that data file. Now with Oracle Database 12c, you can do these things online. So now you'll be able to say, I need to move a particular data file from one disk group in ASM to another disk group which has newer storage, or I need to move it outside of ASM because you're not using ASM at this point. That's fine, but you can do that online. So if you look at some of the quick commands here, renaming a data file, just alter database, move data file. And that movement of that database file will happen at the same time that users are actually accessing it. And access to the various parts of the file will happen as normal. The important thing is this can be done on standard file systems and also in ASM so that you can have full control over where you put the data files. The important thing here is no need to take the files offline or shut down the database so production stays up and running. It can be issued when the database is mounted or open, which means that it also works on a physical standby, whether it's in active DataGuard mode or in non-active DataGuard mode. And there are certain restrictions that apply, such as you cannot have the managed recovery process active while you're moving the data file at a standby. However, the move of the data file at the primary database does not affect the standby. They are distinct separate commands. Another important feature that came about in Oracle Database 12c was the concept of a multi-tenant database. As far as DataGuard is concerned, moving data, i.e. redo from the primary to a standby, is done via the redo stream. So on the left side in 11G, you can see where we have multiple databases that are running production, and each one has its standby. Because the redo generation is done at the container level in a multi-tenant database, DataGuard sees the entire container with multiple pluggable databases as a single standby. So we manage it as one. This further simplifies your consolidation message because now instead of having to manage multiple productions and multiple standbys for databases that have like SLAs, you'll be able to manage one production database, and the same thing, manage one production standby database, or multiples if you desire to have them, but as far as the PDB level, they're all or one. So basically, with a container database, you have one or more physical data guard standbys, but we manage everything at the CDB level. Now, those are the things that are in Data Guard proper that comes with Enterprise Edition. What I'd like to talk about now are the new features in Active Data Guard. Active Data Guard is the database option for Data Guard and was introduced in 11.1 to allow read-only operations and to do fast incremental backups. So if you look at what was in Active Data Guard in 11G, you can see that it was weighted more towards the performance and return on investment. High availability, we had automatic block repair, which says that if you encounter a corrupted block on the primary, we will automatically fix that corrupted block and return the data to the user without interrupting their workflow. The amount of time it takes to get the data block from the standby over is extremely fast because it's very small increments of data coming back across the wire. The same thing applies to a physical standby. We can repair corrupt blocks found in a physical standby by getting the correct block from the primary database. We also allowed you to offload read-only and fast incremental backups. Now if you look at Oracle Database 12c Active Data Guard, you'll see that all of a sudden we're now increasing our Active Data Guard capabilities in the high availability and the data protection arenas, and that's what I'm going to talk about in the next few slides. The primary things we talked about to begin with fast sync is that synchronous transmission is becoming more and more important to our users. The problem with that is the distance between the primary and standby, i.e. the network latency, is what's going to impact the performance impact of a Data Guard synchronous standby. Generally, if you're less than 100 miles, people are fairly confident in doing synchronous transport, more so maybe with the fast sync now in 12c. But as the distance between your production and your standby sites increases, it gets harder and harder to accept the performance throughput impact on your production database. To solve that particular issue, we came up with a capability that we call FarSync. And if you look at a current environment where we're having a primary database in Boston and a standby in San Francisco, you can see that the latency of that network would be far too great to do synchronous transport. So what people compromise and say, well, I'm going to have to accept some minimal data loss, but there will be data loss, and do asynchronous transport. To solve that, we came out with FarSync, but we met some specific guidelines that we wanted to make sure that people understood that this is something that they can implement in all of their database Data Guard configurations and gain access, if you will, to a zero data loss type of configuration. So we obviously had to make sure that it was lightweight. It did not impact your synchronous performance too much, which means that you still need to put this FarSync instance close enough to the production database so that synchronous transport is reasonable, and it can be combined with the fast sync I mentioned earlier. But it needed to be lightweight. So there is no database there. It is not a full database copy. It is merely a few files, as I will explain in a few seconds. But it does not require a separate Enterprise Edition license for the FarSync instance. Even though you install the Oracle Database Home there to start the instance up, it only requires the Active Data Guard license between the primary and any target standbys. The other thing that was important is it needed to be transparent. We didn't want to introduce new types of failover or switchover commands to take a FarSync instance into account, and that's exactly how it works. When you say failover or switchover to my target standby, the one in San Francisco, for example, it's the same command you use today. So if you look at the way you would configure a FarSync instance with Oracle Database 12c Data Guard, we might put a FarSync instance in Hartford, which is within synchronous transmission from Boston. We would ship synchronously from Boston to FarSync instance in Hartford, but Hartford would then ship asynchronously to San Francisco, where our terminal standby is. So if you look at this picture, we have a full production database in Boston, and we have a full production standby database in San Francisco. The FarSync instance is extremely small and lightweight, but is merely forwarding the redo on. However, what happens is when something bad happens and Boston goes away, we lose the production database, synchronous transport is going to stop, obviously, but we have all of the last redo in a synchronous manner at Hartford. So all we do is say failover to San Francisco, and San Francisco becomes the primary, and because it can get to the Hartford FARSync instance, it is going to do a zero data loss failover, even though it's thousands of miles away. Now this does mean that Hartford has to remain available during this failover process. If Hartford is not available, for example, if the entire eastern seaboard lost power, then you would still be able to do a failover to San Francisco. However, you would do the normal asynchronous failover that you would have done originally without the FARSync instance. Now, when Boston comes back, you'll notice that we can just configure things to ship asynchronously from San Francisco back to Boston as a standby once it's been reinstated. The FARSync instance is still there, still running, but it's idle at this point because we're not using it in this particular environment. So to get back to your original configuration, you might say, let's put a FARSync instance in Sacramento. That way I can do zero data loss failovers between San Francisco and Boston. So in the event that I now have a failure at San Francisco, I can do exactly the same failover and go back to the original configuration. Now the first question that people ask is, well, what happens if I do lose a FARSync instance? That's okay. You can put alternates on your FARSync instance. So in this particular picture, you can see that I've added Sacramento 2, which is my alternate to Sacramento, and I've also added Hartford 2, so that I have a second Hartford FARSync instance for when Boston is the primary. They will sit there idle until Boston actually takes over the role as primary database. At this point, though, if Sacramento happens to fail, DataGuard will automatically fail over to Sacramento 2 and continue in our zero data loss configuration. The moment that Sacramento would then come back, we'd fail back to it and allow it to resume the role of chief FARSync instance. Same thing would happen once Boston becomes the primary database. Hartford 2 would be the alternates at that point. Now, if you decided that you needed to add a third database, for example, in Singapore, the Sacramento FARSync instance can distribute redo up to 29 different destinations. So now instead of shipping twice from your San Francisco production database, you ship once to Sacramento and let it do the two over the WAN shipments. So again, this configuration is totally flexible, but allows you to do zero data loss failovers. And in our case here, in this particular picture, I could actually do a zero data loss failover as long as Sacramento was still available to Boston or Singapore and have the same results. So FARSync itself is very, very simple. There's a control file you create from the primary. You copy that, the parameter file, the password file to your FARSync instance. Server, you create a few directories, you start it up in a mount mode, but there's no data files, there's actually nothing else to do there. There's no apply, and then you set up redo transport. Once you start redo transport and the redo starts to come in, the FARSync instance will automatically create the standby redo log files as long as you have configured the log file name convert parameter as we talk about in the documentation. At that point, it's all automatic. Your production sends to the FARSync instance, the FARSync instance sends to the standby, and your failovers and switchovers work exactly the way they do today. As far as sizing this FARSync instance server, the disk space required for the FARSync instance itself is negligible. There's only, like I said, the control file and a few parameter files and password files. You do need disk space for sufficient standby reader log files to match the online reader log files of the primary as per our normal configuration best practices. You also need archive log disk space to handle the largest gap you think you might incur if the FARSync instance cannot send to its terminal standbys. That means if you generate 500 gigabytes of redo a day and you expect that you could have a 24-hour disconnect, then you would need to have at least 500 gigabytes of archive logs to allow it to manage the gap. You will want to increase the amount of space above that to allow for redo to continue to come in while we are resolving the gaps. But again, if you expect that you never will have more than an hour, then you need to have an hour plus some of archive log disk space. But that's pretty much as far as resources. The biggest thing is going to be the I/O speed. You do want to have the system able to handle redo coming in from a very large production system and be able to write to those standby read log files and archive them as quickly as possible so that we do not impact your production throughput. Again, if I/O speed is an issue, you can use fast sync, but you still want to make sure that as you're running in a production mode that you don't get too far behind. You want to make sure that things are always flowing very, very easily. So you do want to make sure that you have enough I/O throughput. The other thing that can be important is that if you are going to use compression with the advanced compression option to compress the redo from the FARSync instance to the terminal standby, you will need a little extra CPU because obviously you'll be doing compression. However, you're offloading this compression onto the FARSync instance from the production database, which is where it's done today. So the benefits, it is truly an ideal combination of attributes. You get the best data protection, but over a much larger environment. And it is really relevant to every single data guard configuration that's out there today. Not only to give you zero data loss failover capabilities to remote standbys, but also as a mechanism to distribute data out to an active data guard reader farm, for example, where you might have 5 or 6 standby databases that users attach to do reads. Today you would send those from the production database in 5 or 6 different redo streams. Now the production database can send to one FARSync instance. That FARSync instance can then forward that redo on to those 5 or 6 standbys, like I said, up to 29 potential destinations. And you can have multiple FARSync instances, not only providing HA for each other, but also spreading the load out to multiple standby databases. Now, another important thing that has been asked for quite some time since we introduced Active Data Guard in 11.1 is the ability to do writes on a read-only database. Now, an Active Data Guard standby is by nature a read-only physical standby, meaning that you cannot modify anything in the database. You can move locations of data files, you can do the normal physical attributes. However, writing DML and those kinds of things are not allowed. In 11.2, we gave you the ability to do DML redirection and send things back to the production database or to another stub database nearby, for example. Now with Oracle Database 12c, you can actually write to global temporary tables. The reason this is possible now is that we have a parameter that you can set on your production database called temp undo enabled, and that allows the undo generated by the usage of a global temporary table to be written to the temporary table space, thereby avoiding the need for any redo generation. This parameter is on by default on an Active Data Guard standby, but if you want to obtain the benefits of the improvements in the ability to write undo to the temp space, you can also turn this on your production database. But this means that now, once a global temporary table has been defined at the primary database, you can use it at a data guard standby with doing normal reads and writes as you have done for years on the production database. To extend that a bit more, we have added sequences. This means that you can now use sequences on a data guard standby and get unique identifiers. And we have global and session sequences now, and session is the new one. As with the global temporary table, the DDL to create the sequence must be issued on the primary database so that the metadata exists in the physical standby, in your Active Data Guard standby. Global sequences, when they're created with the cache and no order options, which are the defaults, work in the manner that when a user says, please may I have the next val of this particular sequence, we actually go to the production database and obtain the next interval for that sequence. And then that standby will use that interval. If somebody else on another Active Data Guard standby or on the primary asks for the next val of the same sequence, they will get the next interval. That means that these sequences, when put together, are actually unique across the entire data guard configuration. And this is important if people are doing various different reports that need to be merged back together at some point. On the other hand, for sequences where people just need unique identifiers in a sequential order, but they don't have to be unique across the entire configuration, we've implemented a new type of sequence called session, and it just adds the session keyword to the create sequence. And now what happens when you say next val, you will get your own set of sequence numbers, and they would be identical to anybody else using the same sequence on any of the other databases in configuration. So the benefits of temporary undo and sequences is obvious. You can now write the global temporary tables, and you can also use sequences in your report so that when you generate information, you have identifiers that allow you to keep things separate. Finally, the last important thing is real-time cascading. DataGuard has had cascading capabilities since 9i, and over the years we've improved upon them and we fixed a lot of the issues. And as of 11.2, it works in pretty much every environment except for two. One, it doesn't do it in real time, and two, the broker didn't support it. In Oracle Database 12c with Active DataGuard, we have now made it so that it is real time, so that when the primary database sends redo in sync or async mode to a standby, that standby can then forward that redo in asynchronous mode immediately to a downstream standby database. This gives you the availability of being able to open the standby 2, as in this picture, and then say, let me see the data, and actually see live data, as opposed to the old manner of shipping when a log switch happens at the primary database. That method is still available, is part of DataGuard, and always will be. The real-time cascading is part of Active DataGuard. So this means that when people have this gold standard, as we refer to it, where they have a production database, they have a local standby for local HA and perhaps Active DataGuard reading, and a remote standby, you can now have the local standby forward the redo so that the primary database does not have to be shipping twice and doesn't have to deal with any kind of network failure over the WAN. So if you look at the two features I just talked about, we have FARSync and multi-standby real-time cascade. Each serves their own purpose. FARSync is not a database. There are no files there. It is very small, very lightweight, and its sole purpose is to forward redo onto a terminal standby somewhere else. Real-time cascading gives you the ability to have a local standby database that can actually be used not only in Active DataGuard, but to failover to very, very quickly, while maintaining a remote standby without the performance impact of multiple redo destinations on your production database. The DataGuard broker supports both of these capabilities now, and as I mentioned earlier, it does this with a redo routes property. The redo routes property supersedes the old log XBT mode. If you look at the way things were today, the log XBT mode property basically says how the primary should ship redo to me. And this works fine until you switch over to an asynchronous standby where you had synchronous standbys. And now all of a sudden, you'll be shipping synchronous back to these two databases, which are far beyond synchronous redo transport requirements, and you'll have to do some reconfiguration. Redo routes takes this to a whole new level. Now it says where, when, and how I, whoever the redo routes property belongs to, should actually ship redo. And this means that now I can not only configure my production database to ship to the various standbys, but I can configure standby databases to also forward that redo depending on who is actually the primary. So if you look at a couple quick examples here, you'll see here that gold standard, these are 3 databases. Any database could become the primary. So I'll give you the example of database 1. His redo route says local, meaning I'm the primary database. I'll send to DB2 in synchronous mode, but I'll send to DB3 in asynchronous mode, so that I now have complete control over how things are sent. DB2 has a similar thing, but he sends back to DB1. The important one is the third one. DB3, being the asynchronous standby, if it became the primary database, will automatically now ship redo back to DB1 and DB2 in asynchronous mode. This is something that couldn't be done without reconfiguration in 11G. If you look at cascading, it just changes a little bit where I say on DB1, if local, meaning DB1 is the primary, it will only ship to DB2 in asynchronous mode. But if DB2 in the next set of rules is the primary, then it will ship to DB3 in asynchronous mode. So again, you have complete control, and each database will change depending on who is actually the primary database. In the third example, obviously with a FARSync instance, the FARSync instance can never become the primary database, so the redo routes configuration is a little bit simpler. In this case, DB1 will only ship to local to DB2FS in synchronous mode when it's the primary. If it's not the primary, it will not be shipping redo. DB2FS for FARSync will ship once to DB1. If DB1 is the primary, it will ship to DB3 in asynchronous mode. And then DB3, this is our original picture. I talked about FARSync earlier, is if it becomes the primary, it will ship directly back to DB1 in asynchronous mode. And obviously you can have other local FARSync instances and add the appropriate configuration to your redo routes for those FARSync instances. So we look here and say, okay, let's have DB3 FARSync. Now I'm going to just modify DB3 to say, okay, you ship once when you're the primary to DB3 FS in synchronous mode. And DB3 is the one that says, I will ship to DB1 in asynchronous mode when DB3 is the primary. So again, you have complete control over who does what and when they do it and who they ship the redo to. Finally, I've talked about most of the new features. There are several other features in DataGuard and Active DataGuard, some of which are not, I did not make part of this presentation because they are other features that can be talked about in other presentations. But all of these are well documented in the documentation in the Oracle DataGuard Concepts and Administrations Manual and in the Oracle DataGuard Broker Manual for Oracle Database 12c. Many of the resources that are out there at your disposal are on OTN. We maintain these with white papers, demonstrations, and training as much as we can. And we also will have links to other features in Oracle Database that work with DataGuard. Thank you for your attention, and this concludes our presentation on Active DataGuard new features in Oracle Database 12c. I hope you've enjoyed the presentation and have obtained some new information. Please refer to the manuals for updates, and as I mentioned earlier, to our OTN webpage for DataGuard and the maximum availability architecture to obtain best practices for all of these new features. Thank you very much. This is Larry Carpenter signing off.